All right, this is chapter 1, number 2. Enter and run the chaos program from section 1.6. Try it out with various values of input and to see that it functions as described in the chapter. So here's our function main with the parenthesis. We're not passing the arguments because it doesn't need any arguments. It's just going to run without the user having to pass any arguments. We're defining this function. And here our indent here, we're going to print this. Defining our variable here. X inside the function, and then for I in range of 10, so that's going to actually be start at 0 through 9, but it's actually 10 numbers. So for I in range 10, X equals, so we're going to reassign the value of X, reassign this product, or this output, reassign that value to X, and then print our new X. So then X goes into, so then we keep X, and we do it again. That X gets changed. So every time this new X gets changed, it gets dumped into here, dumped into here, dumped into here. And then here's our comment, file chaos, anything with that hash, it starts the comment, just hash it once. So we call it file chaos pi, simple program illustrating chaotic behavior. I didn't put a period here, just because it's not a complete sentence. So it's in the book, but I don't put periods in fragments, just because I'm an English guy. So, all right, and then we have to remember, this is just a definition. If we don't have this here, then we're not actually going to see any output. So let's open up our Python. So Python 3.5. Open it here. We could do this in the terminal as well, but and I have ways to how to download all this stuff and how to make sure this is on your computer in the class from before. So hopefully you got this Python 3 shell. So then let's run it. So we're going to go to File, Recent Files. You would actually go to Open and then you'd find it, but let's go to Recent Files. Here it is. All right, so actually I didn't save that, so we're going to save this. So we're going to save it. Let's just open it just like regular. So let's just open, and I just want you guys to see. So then we're going to go to Python chaos pi. All right, so these start. So they have it all be red. They show it as red, which is good. Red means stop. Red means I'm not reading it. This doesn't matter. Not that it doesn't matter, but it's just saying stop. The program's stopping in this part. And then we run it. Run module. And there it is. Nothing. No output. Because remember, we're just defining this function, main. So now let's take that off. Now we've called the function. This is our function call. So we called the function main. And then we're going to run it. It runs. So our function runs. So now we go back to here. And then we're going to open. Let's go open this. Now see, it's black. It's not red anymore. Like those are our comments. Black. Let's see what happens. Run module. So between 0 and 1. Let's do 0.8. Yes, and this is chaos, right? It's chaotic, right? Because it starts at 0 for I in range, so it starts 0. This is going to happen 10 times. It's going to be 0 through 9, right? Range is 0 through 9. So it just says, like, repeat this 10 times. That's essentially what this is saying. And then x equals 3.9 times x times 1 minus x. So x is going to be our number that we punched in, 0.8. So it's going to be 3.9 times 0.8 times 1 minus 0.8. If you do that correctly, let's say you have like a TI calculator, That's what you're going to get, right? Then you take this number, which is our new x, because x has been reassigned here, right? X has been reassigned here. So this is now x, right? Then you're going to print it. Then you're going to take that same number, run this again, second time out of 10. And now x is reassigned 3.9 times this number times parenthesis 1 minus this number. And then this is what you're going to get. So if you use a calculator to double check and just take a look, I mean, this is how you keep it chaotic, right? There's no real rhyme or reason. The assignment asks us to do this multiple times with different numbers. So let's try different numbers. So we got this. Let us recent files. Open this again, and then let's run the module. Sorry, I kept clicking options. Okay, so run the module. So now it's here. We wanted to click it here. I wonder if it'll do anything here. No, it's just, yeah, for some reason. But yeah, sometimes computers. Okay, so let's go to 0.22. Oh, all different. All different. No rhyme or reason. Very different. And we could do it again. Let's run it again. Run module. Run it again. 0.12. So this is a chaotic function. This is the assignment. And I think that we satisfied it. Try out with the various values of input to see that it functions as described in the chapter. Very clearly, looks like there's no rhyme or reason. Number 3, modify the chaos program using 2.0 in place of 3.9 as a multiplier. And then run the program for various input values and compare the results to those obtained from the original program. Write a short paragraph describing any differences that you notice in the behavior of the two versions. Okay, so run the program for various input values and compare the results to those obtained from the original program. Okay, so we want to think about methodically, because you want to start out with simple tasks, simple processes. So as it gets harder, you've already built those muscles of like, okay, what's my method going to be? So a lot of times I'll think about, all right, what's my plan A? What's my plan B? What's my plan C? So my plan A is to use the exact same numbers, right? So we used 0.8, 0.22, 0.12, right? Because we want to look at the same exact inputs that the user enters to see if there's an exact like correlation or inverse correlation, etc. So that's plan A. Plan B might be, okay, let's try different numbers and see, but I think the best route would be using the same numbers. I feel like that there would be some potential difference in the behavior of the two versions. What's another route? Well, I guess we could pick different numbers, but would that really show different behavior? Well, yes, we could talk about that, right? We could say, well, when I entered the same inputs, 0.8, 0.22, 0.12, it seemed like they were still pretty similar in terms of being totally random. But then when I punched in these different numbers, maybe something else happened. So you want to sort of keep your brain open as a sponge for like what the possibilities are, but you want to sort of have a little bit of theories as you're moving forward. This is just, it keeps your brain active, and it keeps you trying to hook. You want to hook things for comprehension, but also for retention, right? For like recall. So that's why I recommend that. Okay, so we've got this open. Let's run it. 0.65. All right. Okay, so I've made a mistake. But yeah, it's totally random, but I made a mistake. Yeah, I need to punch this in. So 2.0. So 2.0. That's all we need changed. So now we saved it, right? Because there's no dot up here in our atom. We go here, and let's go to open. We could go to recent files, But remember, recent files, it still shows 3.9. So because it's recent, it remembers it from before, but it doesn't remember it now. So like really attention to detail. If you thought like I was always academic, but remember, English guy, right? You know, did math, did all my stuff, but you know, so you want to take, you know, you want to take that focus, you want to take that attention to detail and just amp it up, just totally amp it up. With regards to English, yeah, you can communicate, and you've learned the art of a lot of communicative arts that might help with academia, etc. Logic, reasoning, and all that stuff. But this is really about attention to detail, like really, 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 really sharp. So you want to always keep your brain working. So you always want to look what might be different. Well, if I change to 2.0, let's see if this run module, or no, excuse me, this open recent files, if that opens the new one. It actually doesn't. So we just process that in our brain, right? Like recent files means from before. It means not with the new info, because the new info. And the other question is, oh, well, does it remember the old info or the new info? Well, you also might have a default folder set up where you're saving it. You're saving your new ones in a different place than the old ones. And this is not the case because it automatically saves these .py files into Python, or at least we've told the computer to by our last saves, or last few saves. But you always want to check that. Like, what folder is this in? Is it really the same thing? Is this really an issue? So yeah, we'll save it. It's probably already been saved as 2.0, but let's just save it. And remember, the dot isn't there, so it's been saved. So now we're going to go back here, and what are we going to do? Yes, we're going to open. We're not going to go to recent files. We're going to open. So we're going to open it now, and we're going to click open. So that should be new. I thought I did it. Let's try it again. Save as. Cast.py Python. That was wacky. Open. Documents. Python. Now the other thing could be, oh, I have multiple folders of Python somewhere. One of them's over here, one of them's over there. And I probably do. I can almost guarantee you I do. So this is going to save as. So now you want to save this on the desktop, because you want to make sure you didn't make that mistake. So that saves on the desktop. And that's what it's all about. So let's open this. We're going to go to the desktop. There's got to be another Python folder somewhere, hidden somewhere, like inside some other folder, inside some other folder, or inside some, and that's what's messing us up. Okay, so let's go to chaos.py. So you always want to think ahead. There it is. There's 2.0. So there it is. Now we want to run it. Run the module. The good thing about the Python shell is that it saves all this stuff. So it's going to save our last program runs. So we got 0.8, 0.22, 0.12, 0.65. So let's try 0.8. Let's see how it looks. Actually, let's go backwards. Let's do 0.65. Very different. Let's say, oh, well, maybe I made a mistake. Maybe 0.6. Oh, well, we got to run it again. Very different. Look how close they all are to 0.5. Very close. So let us. Oh, here we go. That's why. So it kept showing shell. So excuse me on that. Okay. So shell has their own commands, and then obviously once you click into the program that you've opened in shell, it has their own commands as well. So we've got format and run. So let's run this. Let's run it again. Okay, so what are we going to guess? So what is our theory? Our theory is, well, let's say if it's 0.65, it's very, very close to 0.5, and it's going up, and then it actually gets to 0.5. So 1, 2, 3, 4 runs where it's like below 0.5, but but getting closer to 0.5, and then 6 runs in a row where it's exactly 0.5. I think it's going to be very similar. Very similar. Maybe not 0.5, but maybe 0.3 or 0.2 or 0.9. So let's try it. We did 0.65. Let's do 0. Let's do exactly what we did last time, 0.12. Maybe it's a factor. It's probably not. Maybe it's a factor, 0.12. Yeah. So it starts off with a number, and then it gets closer and closer to 0.5, and then it just keeps repeating 0.5. And it happened here. Because here was so close to 0.5, he only had 4 runs until it hit 0.5 repeatedly. Here was farther away from 0.5, it was 0.2112. So it came closer to 0.5, and then it just had 3 runs of 0.5. This has 5 runs in 0.4. Yeah, so let's try it again. Let's click back here, and then we'll go to run. We'll run it again. Run module. So 0.65, 0.12, 0.22, and 0.8. Oh, 0.22. Same thing. And 0.8. Okay, run module. 0.8. Yes, same thing. So that's what a paragraph would be. We can put it in our comments if we want. As you know, we'd probably write the paragraph and turn it in to Professor Zelle, but let's just write it here in the notes. You could say with regards to, actually, let's just write it here. The first run, 3.9 being the multiplier. The numbers outputted looked random. Looked fairly random. However, with regards to the second run, 2.0 being the multiplier, and I would use the same structure, like the same structure in terms of what you're writing, right? The numbers outputted looked blank. The numbers outputted looked reflected a pattern. This pattern was that the first output of each of the 10 outputs produced from each run this pattern, and it's challenging to be able to write about even simple programming assignments like this. It's just not easy, guys. So just really, but you really want to follow along, like you want to be thorough, and there's a reason that this book is so popular. There's a reason to put these questions in here. So I want us to be thorough with regards to getting this going. So the pattern was that the first output of the 10 outputs produced from each one started out at a decimal between 0 and 0.5, right? Then with each of the 10 total runs outputted in the loop, in the program's loop, the outputted decimal gets closer and closer to 0.5 before ultimately landing and on and outputting (0.5). And I wouldn't put hyphens here because the 0.5 looks really weird outside of that word outputting. So an outputting 0.5. If the first outputted decimal of the 2.0 run was farther away from 0.5, then it took more of the 10 runs, 10 looped runs. They're really runs. Yeah, I guess they're runs. Yeah, they're runs. Because there's the runs in the loop, and then there's the runs, and the amount of times that we run the whole program. So it's a little bit confusing, and that's, I think, what makes it so challenging, and that's why I want to go over this stuff, because we want to be as clear as we can. Then it took more of the 10 looped runs to get to 0.5, and keep on repeating 0.5 as the output. And then you might want to put a sample run, you know. Might not be necessary, but, you know, he's describing, you know, that might be helpful. There's a lot of decimals, though, so it might not be a good idea. But let's just see. Let's see what we can do. So we can go right here. So we can copy that. Let's see how this looks. Oh yeah. So run using 3.9 as multiplier. This is exactly what I would put. And then run using 2.0 as multiplier. So this is our 2.0 run, right? Because this gives a clear illustration. So if we're not super clear, this kind of saves us, because you know, I'm just all about communication. So if you feel like, you know what, I'm pretty clear, but I want to show an example, let's show an example. So we used 0.8. So let's go back up to 0.8 with the other one, because it helped us out. It allows us to paste here, which is great. So then we'll paste right here. So here's the run using 3.9, and you always want to try to make it the same exact spacing, and, you know, if we're gonna make this part of the comments, you know, who knows? Maybe you'll type this out in Microsoft Word and turn it in, you know. But it's just helpful. So, but yeah, this clarifies. This is exact examples that clarifies clarify our description, our paragraph. All right, thank you guys very much. Oh, and we'll save it.